Hi guys. So in this video, we will be discussing about how system.gc method we are using for garbage collection. So if you are using that again and again, it just initiates the process of garbage collection, but it doesn't actually does the garbage collection. Okay, so what steps you need to take? You can help JVM to do the garbage collection process, because you cannot rely directly only upon system.gc method, because it doesn't always guarantee that garbage collection will work for you. Okay, so let me share my screen and explain you 5 simple steps with the help of which you can do the garbage collection very easily, and you can help JVM to do its automatic garbage collection process. Okay. Okay, so system.gc method is discouraged for use. Why? We will be discussing that. System.gc method suggests to JVM that it's a very good time to run the garbage collection, but I already told you, like, it doesn't guarantee that it will do the garbage collection. Okay, so garbage collection, when will it happen? At what point will it happen? It doesn't guarantee that. So there is a chance that garbage collection will garbage collect all your unnecessary heap objects, or there may be some reference pointing to that, and garbage collection is not able to garbage collect that particular object from heap. Okay, so instead of relying directly only upon system.gc method, which can lead to unpredictable performance because you are not guaranteeing the removal of heap objects, so what the next necessary steps that needs to be taken, that we will be discussing it further. Okay, so it's generally avoided. So what are the alternative approaches to resolve this issue? We will be discussing that. So first approach is let JVM manage garbage collection. No, right? Java has automatic garbage collection process. Okay, you don't have to manually go and clear the object from the heap memory as it was there in C. So if you remember C, there is certain thing called calloc as well as malloc. Okay, so it was used for creating the memory allocation and removing the memory allocation. Okay, so those things we have to do it manually in case of C for removing the heap objects. But in case of Java, we have been very much grateful that we have been gifted with automatic automatic garbage collection process with the help of JVM, with which it's pretty good. Their JVM is pretty good to manage its own garbage collection, and we don't have to think about it. So let's give the task to JVM only, and let the JVM decide, like, at what point of time JVM will do the garbage collection. So we should not intervene that in between. Okay, so we should not use system.gc method in between and initiating it. Rather, we should let this task be with JVM and let the JVM decide, like, when JVM want to clear the objects from the heap. Okay, so this is very important, first point. Second point is profile and optimize. Okay, so if you're experiencing like a lot of performance issues are coming, like out of memory issue, memory leakage issue, these type of things are coming. Okay, so it's better that to do the profiling of your application, so you can see like where and all memory leaks are happening. Okay, so there are certain tools that you can make use of, certain tools like visual VM you can use. Okay, so with the help of which you can exactly analyze like which and all places the memory has been getting leaked. Okay, so wherever you can see memory is getting leaked, you can just go over there, you can see the task, and you can stop the task if it's not in use. So with the help of that, you can get more and more memory freed up. Okay, and because of that, your system performance and your application performance will get improved drastically. So profiling is very important. Then comes third, try with resources. Okay, so all the resource management which you are doing in our project, okay, Java projects. So what are type of resource management we can do? Like buffer reader. Okay, so we have created one resource opened, like you have created one connection in JDBC. Okay, there are certain thing called as prepared statement, connection con, we are using that reference. Okay, so you have to close that reference whenever we are making use of it. So if you are not closing it, if it kept on open, then there is a possibility of leakage. Okay, so object memory leakage can occur because of that particular object. So we have to make use of all those objects which may create a chance of leakage. We should put it in try with resource section. So how try with resources work, you already know, right? We will be writing try, and within that we can put a bracket, and there we can write it like buffer reader br equal to new buffer reader, and then you can make use of it. Okay, and then if you close it, then automatically after execution of private resources, you will see that that particular object is garbage collected automatically. You don't have to write it specifically in finally block, like if connection is not equal to null, then connection dot close, you don't have to write it. Okay, yeah, so you don't have to write it again and again. So once you have written it within try with resource section, then automatically it will be garbage collected and the object will be removed from the heap as soon as the process gets finished. So all those objects which are getting created and there is a chance of leakage of that resource, then in that scenario you can put it with private resources. Okay, so if it's not closed, then by default it will get closed when it's no longer needed. Okay, so it will prevent resource leakage and unnecessary memory consumption. So the fourth point is we should avoid creating unnecessary object. So we have seen like there are a lot of instances where in our project we are creating unnecessary objects. Okay, we are creating unnecessary objects, so which are not in use. Okay, so we should be taking care of it. Like if you are creating one unnecessary object which is not being used, then it is taking space in the heap memory. Okay, and because of which it creates a lot of havoc. There are no it is used in the project, so because of that garbage collector is not coming to clear it off. Okay, and it is being present in the old gen from long time, so that is creating a weightage. Okay, so you have to make sure of it, like whenever you are creating an object, try to delete it, okay, with the help of clearing it. Okay, so you can check it, like if that particular reference is not equal to null, then assign that variable to null, whatever you have defined. So in that way you are helping JVM for garbage collection. Okay, so we should be thinking of it like if you are creating too many temporary objects, it creates a lot of pressure on garbage collector. Just think it like this, like you are working and one task you have been granted to work, and at the same time after 10 minutes one more task has been put up on your head, then after 10 minutes one more task has been put up on your head. So how many tasks can you do at once? Only one task you can do, right? So there is unnecessary pressure is coming on your head, and you know that you are not able to perform better if those many task is coming at your head again and again. So you need to keep your head simple, right? So similarly, you have to keep your garbage collection process simple, and we should not put so much pressure on it, so that garbage collection process, which is being automatically done by JVM, it will clear out all unnecessary objects from the heap memory. So wherever possible, try to reuse the object or use some data structure which has minimized time complexity, just like hash map. Okay, so with the help of that, it will minimize the object creation process, and we should make use of string builder rather than string, because string is immutable in nature, right? So whenever you are making use of string and you are trying to modify the content of the string by doing some operation on it, then it will create a new instance. Okay, so it will leave the old object dereferenced in the heap. Okay, and every time you are making some operation on it, it will create a new instance. So you can see, like if it is running in a loop, then every time you are creating new instance of the string. If it loop is running 100 times and you are doing operation on string, then believe me, 100 new instances will be created and the heap memory will be fully dumped up. Then you can think like what will be the impact on garbage collection process. Okay, garbage collector will blow away. So instead of using concatenation, okay, just try to make use of string builder.append method. So that will be very much helpful. Okay, and fifth point is weak reference we have to use. Okay, so weak reference, and there is certain thing called as strong reference. Okay, if you go deep into hash maps, you will get to know there is certain thing called as weak hash map. Okay, there's certain thing called as normal hash map. So in weak hash map, what it is, there is a weak reference pointing to it. So whenever you are making use of weak hash map, then it will, garbage collector will keep on looking at your particular object like till a particular threshold of time. If there is no other references pointing to that object, then automatically it will be eligible for garbage collection. Okay, so that is very much helpful for JVM to clear out the objects from the heap if it is not being used. So we have to make use of weak reference wherever possible. If you are thinking like this particular object is not to be used, okay, at later point of time, and this is being used only at this particular scope of the method level, then its best way is to try to check if data is null, if field is null, then if it is not null, then assign it to null, or make use of private resources, or make use of weak references. So with the help of which you are helping JVM to clean up the process, clean up the garbage collectors. Okay. So weak reference allow object to be garbage collected when they are no longer strongly reachable, which can help prevent the memory leakage. So it's very much clear. It's very much important for interview perspective as well. Okay. So whenever you are using weak reference, you are telling garbage collector like, I am always available for garbage collection. You can check for a certain period of time. If that during that period of time no other memory is being referenced to my memory allocation, okay, to my object, then in that scenario you can come and clean me up. So that is the meaning of weak reference, which is being advised to JVM to do about my object. So these are the things that we have to think upon. Then the last and most important thing is you have to tune the garbage collection. Okay, so these type of statements you can make use of to tune it. Like there's a collection settings are there in JVM with the help of flags like -xmx and -xms. So these things we can use to maximize the initial heap size. Okay, you have to maximize the heap size. So there is a chance like your project is very heavy and the given default heap size is not sufficient to allocate the memory for your project. Okay, it takes a lot of memory. So in that scenario, what you can do, you can just increase the heap size. Okay, and then it will be helpful for your project to go. Otherwise, it will show out of memory error. Okay, so you have to understand it. And you can then there is something called as use G1 garbage collector. So G1 garbage collector has been recently put up after Java 8. So it is very much helpful. It keep on increase. It helps in increasing the memory in such a way that it will be used however what particular part you have been using. Okay, so let's suppose you are using only 60%, so you can set it up like till 70%. Okay, and 60% will be used up, rest will be set aside. Okay, so for extra space, so you can make use of those flags like -xx : plus use G1 GC. Okay, or use concurrent mark and sweep algorithm. So these two are algorithms. Okay, so these are very important algorithms. You should be understanding this, like mark and sweep algorithm, concurrent mark and sweep algorithm, G1 garbage collection. Okay, so with the help of this, actually it marks where and all which and all objects are there which are not been referenced to by any other object. Okay, so it will just mark it out, and out of 10, let's suppose 7 objects are there which no other objects are referencing to that. So in that case, this mark and sweep algorithm will sweep those objects and it will move to survivor space. So there is certain thing called as young gen and old gen. If you go inside garbage collector, you will see this concept called young gen and old gen. So young gen means new objects which are getting created, and within young gen there is certain thing called hidden space and survivor space. So whenever some new object are getting created, so first it goes to hidden space, and then during the next garbage collection cycle, it will check like, is there any objects or classes pointing to that particular memory reference? If there is nothing like any object is pointing, then it will sweep it. Okay, and it will remove it. And if there is any object pointing to that particular object, okay, which is then hidden space, then garbage collector will not be able to remove it because there are certain active references are there. So it will just move it to survivor space. Okay, like S1, S2, and after 2-3 cycles, then if there are certain objects which is not yet set for removal because there are certain active memory linkage, there is active memory references pointing to that object, then in that scenario that object will be eligible to move for old generation. Okay, so if once it goes to old gen, then there will be not frequent sweeping. Okay, there will be not frequent garbage collection process happens, but you can understand like within 10 days or within 20 days garbage collection will happen. There will not be such frequent operations. So use this concurrent mark and sweep GC, so it will help to remove the unnecessary object from the heap more frequently. Okay, and it will help JVM to remove the object, and it will help it to do the garbage collection in a much simpler and in an efficient way. Okay, so efficiency is very much important, and you have to think before writing a code. Before doing any kind of development, you have to think like, if I'm writing this code, will there be any issue with the memory? Okay, will it not create any memory leakage? Okay, am I not closing? Okay, am I closing any resource which I have been opening, like connection you are opening, or any resources you are opening with buffer reader, buffer writer? Are you closing those resources, or are you using private resources? Those things, if you have to keep in mind, then you will see like garbage collection process will be faster, and you don't have to think about this memory issues. Okay, I hope you got the clarity, you got the concept on this. So we'll see you. It's Devjit Roy signing off. We'll see you in the next video with next set of concepts. Bye bye.